Delighted to introduce Elliot Hems, who is the MD of IPG Automotive UK.
Today I'm going to try and share my views and give my opinion of why I think we can trust simulation and get it in there for the panel discussion. I've spent a couple of decades now working in the automotive industry, first half largely in physical prototypes, repeating similar patterns of work as new phases of prototype came along, until eventually I saw the light and I moved into a simulation role. Never really looked back from there. And I now lead a fantastic team of engineers, simulation engineers in the UK arm of IPG Automotive. And IPG Automotive it's a 35-year-old company, subsidiaries and customers all over the world. My role gives me an extremely privileged opportunity to work with lots of customers, major OEMs and tier one suppliers in software, hardware, engineering services and consultancy. So if we move on to the next slide. Okay, so why am I here today, other than obviously I can't go anywhere else right now? I'm here to share my observations and hopefully be a little bit provocative. I am deeply passionate about simulation, and particularly virtual engineering and the methodical and targeted approach to problem solving that simulation takes. I'm fascinated by our recent recognition that simulation hasn't really scaled across large businesses. Now, I don't mean to say that there aren't examples of simulation genius across all of the companies that I work with, but there is still clear resistance to virtual development being at the core of the development process. And let's not kid ourselves, there is absolutely resistance. Now, I'm not here today to tell you, as the other panelists have said, I'm not here to tell you either that simulation is the answer to everything. Absolutely not. It's not the perfect answer either. But if we move to my next slide, you'll see that as an example, in October of last year, the AAA in the USA concluded a piece of research. And this research demonstrated that AEB for pedestrian detection on a number of production vehicles that they tested performed abysmally during their physical tests. Now, the difference between, say, a 20 mile an hour to a 30 mile an hour test was catastrophic. A difference between day to nighttime tests, again, catastrophic. So again, I'm not here to tell you that simulation is the answer to this. I'm here to tell you that physical test alone clearly isn't the answer either. And I don't think we should be trusting our life to that on its own. It's a combination. The legacy development methods in physical prototypes have typically been slow, clunky, and often wildly unrepresentative of what will eventually go to market. And so I think it's very important within that to also draw out that the sample size of physical prototypes is far too small. And as Jeff just talked about, the industry problem of exponentially growing vehicle complexity, it cannot continue to be tested physically. It has to be tested in the virtual world as well. So moving on to the next slide. Mark Matheson yesterday in his presentation on behalf of McLaren commented similarly to my experiences that these early, very expensive prototypes in the test phase tend to spend more time, at least my experience, being fixed or updated, or some kind of troubleshooting or car park testing, as it's often called, than actually being tested for decision making on the program itself. And so I would like to see these early prototypes removed and replaced. It's a slight contradiction to Giancarlo's opinion, by simulation, and try and answer very specific questions using simulation such that the performance tuning and the validation prototypes later on in the vehicle programs are built much more robustly. They're far better, they can be used much more intensively, and indeed they are or should be much closer to production intent. So let me give you a couple of examples of where I've seen resistance in the past for embracing simulation. One of them is, so you can't possibly use ABS for testing in simulation. You can't do it because the high slip dynamic capabilities of time modelers just don't exist. Well, what about if we want to test something simple? What about if we just want to look at split new braking? Does the correct side of the car pulse the brakes? Are the inputs and outputs correct? Are the CAN signal infrastructure, is that correct? Diagnostics and so on. Sign conventions in the code, simple things like that. There are huge swathes of tests that can be performed for ABS testing with a dodgy time on. Another one, ideal sensors for modeling ADAS, not sufficient, can't be done. Well, again, let's take a simple example. If you want to have a look at where your sensors are positioned on your vehicle and assess under a, I don't know, heavy braking, maybe pitch condition, are the sensors still pointing where you want them to point? Again, super simple. An ideal sensor model, absolutely fine for that. So we need to take the approach of purpose-driven fidelity. What's the absolute minimum level of fidelity required to answer the very specific problem you're trying to solve? And let's focus on that. Start with that and then build up. And I love Robin's points about the complexity and the millions of objects in the scenarios. You build up to that. You don't start with that, you build up to that. And then those tests become even more relevant and even more credible. It's not about, as I see often, trying to make the real or the simulation world exactly replicate the physical world. It's not going to be possible. It's not going to be relevant in a lot of conditions. And I guarantee you those early physical prototypes don't represent their version of the targeted reality that they're intended for well enough either. So moving on to a slide that briefly I'll touch on one of the critical steps in this journey. So to illustrate the problem here, if we take the simulation village or a region of villages, a long-established approach to water supply, wells and streams and buckets or whatever it might be. Now that works quite well, and each villager has access to water with varying levels of quality and varying levels of availability. That is very similar to data in big companies, well, and small companies in fact. And it's not sustainable for growth. It's not sustainable for scalability. What you need is an infrastructure project that puts in place a centrally built, managed, maintained and used water supply, exactly the same as data, models and processes. And that allows us to scale. This is where I think industries need to make fundamental changes in their approach to data. And they should be treating data and models in particular and managing them as strictly as they do physical parts. So just on my last slide then, please, Sunny. How do we transition into a world of simulation being the central core of vehicle development? Sarah Kenny said it beautifully yesterday in her presentation. The problem is not the processes, the problem is absolutely not the technology. The problem is with the attitudes and the willingness to change. And I said I'll be slightly provocative at the start. Just because an OEM or a tier one or a company of any sort has spent a number of years or maybe a number of millions of pounds or dollars investing in a process that is not yet successful, doesn't mean you should keep pumping money or years into that process. Cut your losses, fast fail or slow fail, depending on the approach. As Peter Drucker said, culture eats strategy for breakfast. And I think that's really important that we take that approach. Be very specific about what is the problem you're trying to solve. Let's focus on that and let's move into that problem solving architecture.